Alright, we're back at it with another week. Last week we just simplified fractions. That's it. A lot of factoring, a lot of canceling. That's all we're going to do this week as well, but we're going to be multiplying and dividing rational expressions. So a couple things I want you to recall. We'll start with multiplying. When you're multiplying fractions, you multiply across the top and then across the bottom. So you look at my example, I have a over b times c over d. I just straight up multiply a times c, put it over b times d, whatever that is, it becomes one fraction. So the first thing I want us to do when we're doing these is factor, and then we're just going to cancel like terms, and then after that we just rewrite what we got going on. Alright, it's a lot of what we did last week, just a little bit more with the fractions, that's all. Alright, so we move on. Let's look at examples. I think I have 7 total, 4 multiplying, 3 dividing. I'm just going to do the factoring types, not like some of the first ones we saw last week. So let's just check out the factoring. And again, I'm going to keep it pretty simple. A is 1 on the trinomials, and then GCF. That's about it. Perfect squares as well, if you guys remember that. First example. Start off with something fairly basic. Made note here, it's already factored. Alright, don't need to factor. So it's already factored, we're good to go. Move on. We're going to treat it as one fraction. So we're going to treat it as one fraction. I don't need to see it as one fraction. We're just going to treat it as one fraction. Alright, so that's why I put that big old fraction bar just through the entire thing. Then we're going to cancel out the like terms. I look here, I have x plus 4s. I have 1 on top, 1 on the bottom that can cancel out. If you look, you're looking at what else can cancel. Well, I got an x minus 3 up top. I got an x minus 3 on the bottom. X plus 2 and x plus 5 are not like terms, so I can't do anything there. I did make a note here. Around these, in the beginning I didn't have parentheses. You can put parentheses around them if you want. Not a big deal. If you don't, just know that you can cancel out the x minus 3 as a whole with the x minus 3 on the bottom. That's all. And then we rewrite what's left over. Now, big thing here compared to last week, remember, you cannot cancel out these x's. This is it. That is your answer. X plus 2 and x plus 5 are not the same thing. These x's, even though they are both x's, would not make these fractions equivalent if you canceled them out. Alright, so this is your answer. That's what our answers are going to look like for the most part. There may be some extra terms in there from time to time, but that for the most part is what we have. Again, a lot of this is going to be 1, maybe 2 steps and then the answer. Alright, so I need to see this factored step. I'm not going to give you any like this where it's already factored. So I need to see the factored step and then the answer from there. Alright, so it should be pretty easy moving forward. Just a matter of how comfortable we are factoring. Alright, this one. X plus 7 over 7x plus 35 times x squared minus 3x minus 40 all over x minus 8. Got a little bit of factoring involved here, so let's check that out. So first step, factor. I don't care what you have. Don't try and cancel out these x's, nothing like that. Factor first. So I just rewrote it, factor first. Just some reminders here in this first one. You're looking at factors of negative 40 that add up to negative 3. And you're looking at a GCF here. 7 and 35 have a GCF of 7. So factored, here, let's look at this real quick. Factors of negative 40 that add up to negative 3 are negative 8 and 5. So remember that. So it's x minus 8, x plus 5. X plus 7 cannot factor. Neither can the x minus 8 on the bottom. But I can take out a GCF on the bottom here, and that'd be a 7, and then times an x plus 5. Everything's factored. Once everything's factored, you treat it as one whole fraction. Whether you draw one fraction bar or not, that's up to you. You cancel out like terms. Like terms I see are x plus 5s. I also see an x minus 8. Now, the x minus 8 up top is in parentheses. The x minus 8 on the bottom is not. Not a big deal. I told you in the last problem you can put the parentheses if you want. It doesn't matter. Alright, notice here I did not do that. Big thing. Sevens cannot cancel. We rewrite what's left over. And again, sevens cannot cancel. It's not the same thing. So it's x plus 7 all over 7. And that's your final answer. And that, for the most part, is what we're doing. All right, so it shouldn't be anything too crazy for us, hopefully. Little twists here and there, but that's it. All right. Speaking of twists, we got one right here. We got one fraction times another term. X squared plus 7x plus 12. It's not necessarily a fraction, but we treat it like a fraction. This term, this parentheses, is technically all over 1. So it's up top in terms of the fraction. We factor first after we realize it's technically over 1. These two factors are just like the factoring we did in the last one. I'm always going to, not always, but in our notes, I'm going to give us a reminder of a GCF. That one, greatest common factors, we usually tend to not see as often as the other types of factoring. So I'm going to give us reminders in that direction on each one. So we factor GCF 4 times x minus 2, factors of 12 that add up to 7. We got x plus 4 and x plus 3 all over 1. I put it in there this time. All right, last time I just kind of drew it in, but that's the way we need to treat it. Factors of negative 8 that add up to positive 2. We have x plus 4 and x minus 2. Treat it as one fraction. Need to extend that, but you treat it as one fraction. Whether you write that or not, again, I don't care. You take a look. I'd be asking around. What do you see that's in common? What do you see that can cancel? I'd be getting an answers of x minus 2s, x plus 4s, hopefully. Alright. We kind of look at what we're left with here. We have a 4 out front. We have an x plus 3 on top, and we have a 1 on the bottom. That's all we have left over. So you can write it as I just said, 4 times x plus 3 over 1. But we know when the 1's on the bottom, I don't necessarily need it, so you could just write 4 times x plus 3. You could also write, if you wanted to, let me kind of get that typed in here while we're doing it. If you want to, it could be 4x plus 12 if you distribute that. Alright, personally, that's just extra work. I'm not looking for that. I'm looking for boxed in answers. Alright, but it could be 4x plus 12 if you want, if you distribute that 4. Alright, that's fine too. So we got that. We got one more problem here. This is all the types of factoring that we could be seeing. We have factors of 25 that add up to 10 in the middle, perfect squares here, GCF up top, nothing on the bottom. This is the most we'll see on any factoring. Alright, I promise you that. So we look, first step, factor. I give you the reminder of a GCF. This one is the first time it popped up, so I'm telling you it's perfect squares. So, go ahead, factor. What factors of 25 up to 10? It's 5 and 5, both positive. Difference of squares, remember, it's kind of the square root of each one, x plus 3, x minus 3. One's a plus, one's a minus. Top here had a GCF of just x, so we take out an x times an x plus 3, and then we'll just have the x plus 5 on the bottom here. Treat it as one fraction. Let's see if I can extend that at all. Maybe. Like I said, not a big deal if you can't. I'm going to, because I'm more particular. So we got that. Now, I see an x plus 3 that can cancel. 1 on top, 1 on the bottom. Now, I have 2 x plus 5s up top and only 1 on the bottom. It's a 1-for-1 deal, so I can cancel out 1 x plus 5 up top with the only 1 on the bottom. Alright? So I need to only cancel out 1. You can't cancel out both. We rewrite what's left over. You have an x plus 5, you have an x up top. Then you have an x minus 3. These, again, x's cannot cancel at all. This is your answer. I have your answer boxed in. Just make sure you're not canceling out those extra x's. Alright, that's multiplying. Hopefully nothing crazy. I'm gonna, like I said, this is the most you're gonna see in factoring on this slide right here. Move on to dividing pretty quickly here. I'm running out of time with what I have and what I'm able to record. When dividing, you're gonna flip the fraction after the symbol. So if you look here, I have a over b divided by c over d, similar to the last or the very first slide. You flip the first or the second fraction, the fraction after the symbol, and then you just multiply. Dividing is essentially multiplication. First thing you do is you flip, then factor, then cancel out like terms. Flip, factor, cancel. Alright, we have this. We saw similar setups. Factoring is not changing. The only thing I need to do is I need to flip that second fraction. So the first thing we do is flip. I don't even factor first and flip at the same time. I just go ahead and flip. So I flip it, factor. Alright, I treat it as one fraction. Cancel out like terms. I have an x plus 5, or x minus 2, sorry. X minus 2. I have an x plus 3 and an x plus 3. Rewrite what's left over. X minus 5, x plus 5. Nothing can cancel. Do not cancel anything out in this scenario here. It looks very similar. Do not cancel. Next one, I only got 2 more here. A little bit more factoring. We're getting deep into this now, but you still need to flip first. I do that before I do anything else. Flip first. Then factor. These are the 2 steps I would need to see. Flip and factor. Alright. Treat as one fraction. Cancel out your like terms. I got a lot more to cancel out on this one. I have an x plus 2, top and bottom, x plus 3, top and bottom, x minus 4 is top and bottom. It's the most I've had to cancel out in any problem. That's okay. Sometimes everything cancels. Not often, but sometimes. All I'm left with up top is x minus 1. All I'm left with on the bottom is a 5x. There you go. Right, what's left over. Last one, little twist in this one. Alright, now I'm going to show this in a couple steps here. We have this fraction, similar to what we've seen before, but we're dividing here. Be careful. That is technically over 1. You flip first, so it's technically over 1, and I'm going to flip this, so it becomes this. There we go. 1 over 3x minus 24. It starts over 1, you flip it, it becomes 1 over that. We factor, treat it as one fraction, cancel out what we have, x minus 8, x minus 6s. This is the least I've been left with, and again, that's just fine. I'm left with 1 over 3x. I have an x here and I have a 3 here. Don't forget both of those. It's 1 over 3x. Alright. And that's all we got. Alright, so it's factor, cancel. Division you flip first though. Alright. Those are the three key steps you're really doing here. You flip potentially, only dividing. Factor every problem, cancel every problem, something can cancel. This week you got, just like last week, it's a repeat of last week, you have your survey, you have your worksheet. I'm going to give your answers to the worksheet again, but I need to see the factored step. I'm only going to give you the answers. I need to see the work. If you don't show work, you don't get credit. Alright, if you have questions, hit me up at any point throughout the week. I'll talk to you guys when I talk to you. Alright, see you.